Dennis waved
I'm-
his hand and says,
Wait, there's a party?
Yes,
Oh, good.
it's already started.
so what does the F stand for? First introduce yourself.
All right, I'll start with that. That's the easy one. I can answer that question. My name's Eric Klein, and I am the president of the VCF. And again, the F, as has been hinted, stands for several different things. We're kind of playing games with our name. Who here was at this year's Vintage Computer Festival? All right, we got a couple people. Why didn't the rest of you show up?
Everyone else is slackers.
Yes, slackers.
Well, I mean, I'm asking for a reason. You guys heard about it, though, right?
Yes.
Okay, well, that's
announced.
Excellent. Well, that's better news than I'd thought. We had what I consider to be sort of an advertising problem this year, so I'm working on trying to improve that going forward and getting more people to come up to this show.
There were several vintage computer festivals, is that correct?
So there are a number of vintage computer festivals. There are several formal ones, meaning ones we sponsor. The ones that we sponsor are the one that we just finished, which is VCF West. The next one will be VCF Pacific Northwest up in Seattle. That one's in March. We just announced the new date for that one, and we just put up all the registration materials online this weekend. Vintage Computer Festival East will be in May. I think they're still locking in a date. Hopefully they don't lock it in on the same weekend as Maker Faire is out here, because that generally makes me very angry. Because I'd like to try and help participate remotely with that show if I can't fly out there, but Maker Faire is a big deal for me. And then we had our first VCF Italia this year. So in this particular case, the F stands for festival. So we have 4 formal vintage computer festivals that the organization hosts, and then, and I'll get into a little bit of the history maybe a little bit later, but the Vintage Computer Festival started, I want to say close to 20 years ago at this point, and the guy that started it ended up turning over the IP to us, but several people borrowed on that idea prior to us setting up the Vintage Computer Federation. That's another part of the overloaded F. So there are other people that use the same moniker. So there's one in Germany, one in London, I believe, and then there's the Southeast and the Midwest that are doing the same basic thing. A bunch of geeks with old computers setting up displays and having fun, but they're not quite formal members of the Federation. It's a little confusing. It's not actually all that big a deal. We're all friends. We all work together and we help each other out. They show up at our shows. We show up at theirs. That's all. You know.
There's multiple fourth interest groups now.
Yeah. Well, you know, sometimes that's a good thing. Sometimes, you know, it does get confusing. And then, of course, the contribution I made to the Federation when we sort of drew our forces together, and this would have been close to 4 years ago now, was the Vintage Computer Forums. Who's heard of those? No one? Wow. All right, well, Vintage Computer Forums are an online forum that I had started to discuss, obviously, vintage computers. And they took off like a shot, and at this point are the largest forum online for that kind of thing. I'd probably guess that places like Facebook are overtaking us at this point, but there's still hundreds of active users, thousands of registered users, and plenty of eyeballs on that site every time. So it's the other overloaded part of the F. So while I'm standing here, what is it that you guys are all about besides just using what is it, almost 50-year-old computer language?
That's it.
It never goes till it's over.
November, it will be, what, 50 years, right?
Yeah?
Yeah,
Pretty close.
You can't get us to agree on much else
Then the age?
than fourth. And even there, which fourth?
That's true, yeah.
And just to be clear, C and fourth are contemporaries with each other. So C is also almost 50 years old.
Oh, yeah. No, there's a bunch. Basics older still. Obviously, the Fortrans and COBOLs are even older still. So it just depends on, you know, again, what version you're using. They've been modernizing C quite a bit. I'm not sure about fourth. I just don't know.
Occasional efforts, all of them bashed.
Right on.
There's a lot of non-standard things being done in fourth, but there's also a new standard, I think, the 2000X.
The 2000X standard continues to go. Next month, they will have another meeting. They have one every year. They're still getting proposals. The latest one is recognizers, is the latest thing that's happening.
TS Truths recognizes it extends the text interpreter.
Yeah.
Yeah.
So yes, activity is still going on. It has all along.
Yeah, well, I believe that for sure.
Yeah.
It's
just convincing this group of people to do anything the same is interesting.
Yeah, I was going to say, that sounds like a common problem.
It is. And I was actually on the standards committee when it was the standards committee. It's tough. It's real hard to do.
You mean the ANSI?
The ANSI standard. Yeah. When it was the ANSI or IEEE standard.
All right, and you guys meet here monthly?
Yes.
Yeah.
And
every fourth Saturday,
Except for the ones we don't.
right, that's every third.
November, December, and Maker Faire.
Yeah,
Maker Faire we usually don't meet at all, except for when we do.
do you guys have presents at Maker Faire?
We used to.
Used to.
We did, but Ting recently.
Yeah, I think I gave up the position and nobody took it.
All right.
He keeps on threatening to retire, but he still shows up.
All right, well, just trying to get a feel for what you guys do and, how geeky you really are. I think it goes to 11. And just so I can put these things down, I brought presents. These were giveaways from VCF. ACM sponsors us every year and gives us a bunch of toys. Unfortunately, they give us too many toys, and I need to get rid of them, and I don't want them in my house. So they're going to your houses.
Okay.
Brought a pile. They're over in the corner. These are just little pencil case, cable case, whatever you want to use them for. I think they fit most microphones, too, if you're into that kind of thing. And then luggage tags. Everyone needs like a dozen of these.
Absolutely.
All right. There you go. Get them out of my hands. So one of the things that we do with regards to the Federation, the Finnish Computer Festival is one of what I consider our community outreach events. Maker Faire is another one. And Maker Faire is sort of my favorite, depending on how you look at it, because for the Vintage Computer Festival, I run the West Coast Fair, right? So I'm the one that's got to pull all the crazy hours and crazy effort to get that thing going. And I'll show you some pictures of it in a little bit, but that means that I can't show off my toys. I can't have a booth. I can't do what I consider to be sort of the fun, casual stuff because I'm running the show. So Maker Faire is my opportunity to go out there and play with toys and show off toys. So for the last half dozen years or so, I've been setting up a large booth at Maker Faire. I usually get a 20 by 20 from those guys, put a dozen tables in the space, and my friends and I pull together a display. So if you guys are interested in the Maker Faire presence, you keep in touch with me. I will send out my announcement as usual. Let's see, it should be about 2 months for Call for Makers, and then about a month after that, so sometime in the February timeframe. At the latest, I'll have final approval for my booth, and I usually start doling out tables at that point. So if you guys want a table or two of those dozen to draw in some more people to your club, let me know, and we can probably figure something out. And a couple months after that is the next Finnish Computer Festival. So first weekend in August, every year in perpetuity. I'm trying to grow it, both in attendance and in exhibitors. So I know that we had a fourth table at the one 2 years ago. I don't know if that was you guys or not.
Yeah, 2 years ago.
2 years ago, it was you guys? Right. Haven't had it since because, you're not going to Maker Faire anymore. You're retired.
Well, we were told that our exhibit was not interactive enough
By
the person that we contacted at Maker Faire.
Oh, at Maker Faire or at Vintage Computer Festival?
Oh,
That wasn't a
yeah.
Vintage Computer Festival, I don't think.
No, that might have been Bernheisen in Germany.
Okay, it's possible.
With the, he was playing the Go with the little robot.
Yeah, I think so.
Yeah, that's parenting.
Okay. So if you guys wanted to have a booth at VCF, I think it would be a wonderful addition to the show. It's perfectly within the line of our vintage festivities, similar to these festivities. Maybe a little bit.
Calling us vintage?
I've been calling myself that.
Oh, okay.
All the tokens have to be harvested in a given year.
Usually the way I look at vintage is it's more cranky, but that's just because of the machines that I got in my collection. Anyhow, so if you guys are interested in the both the Maker Faire presence, because that's one of the VCF's community outreaches, and the Vintage Computer Festival itself, let me know. I'm especially interested in getting you guys into the VCF. There's always room for more at the Maker Faire, and if we fill up the booth and we keep getting the kind of attendance we get, and our booth at Maker Faire is crazy, then they'll keep giving us more space. They love us there.
Question. What about, so like I am making my own computer from scratch using FPGAs. It is built around the fourth environment. But it's not like a retro environment. I like to call it a neo-retro environment because I want the look and feel of a retro computer, but it's a new design or whatever. Like how would that fit in?
It would fit in wonderfully. Let me see if I can keep this machine logged in. Skip through and see if I can find this picture. So, yeah, so these guys have done very similar stuff. That's FPGA-based, I believe FPGA-based PDP replica. And Altair and Kenback replica. And one of my other favorites, if I can find a good picture of it. Come on, guys. I always have pictures of this one. Well, it's over there, but I can't tell. I'm giving you a preview of all the pictures. How's that? I might not have it in there. Anyway, there's another gentleman who's done a full TTL implementation of a 6502.
The monster.
The Monster 6502. Yeah. So Eric Scheffler, that guy there, right next to Chris. Chris is the guy with the open mouth. I don't know if you guys are familiar with the Computer History Museum.
Yeah, I got a question. Did they use TTL?
I think it was TTL.
Did they use the Schottky 181?
No, it's discrete MOS transistor.
Discrete MOS? These little network that works at Calpon.
No.
They had a graphics engine that was based off of the Schottky 181 CPU plus.
Yeah, no, this isn't at all CPU based. It's all discrete. Yeah.
3,501 MOS transistors, just like the silicon die.
Oh my God! You mean boy, that thing must be just as big as
No, it's actually really cool.
Really?
Yeah, he's running it at I think a quarter speed, half speed or quarter speed.
Yeah. What's that?
Physically and thermally.
Yes.
There it is.
Yeah.
So that is a 6502 processor, and he's actually running an Apple II, quote Apple II off of it. So yeah, the short answer, or the long short answer is that yeah, something like that would be a wonderful addition to the show. And if it's fourth based, you know, it's one of those things where you can have that as part of a exhibit, and then the other half of the fourth exhibit is, you know, code examples and teaching people simple stuff, and maybe having a running environment of that. Very cool. I like that. Modern recreations tend to fascinate me. I don't have the technical skill.
So this is a new design. But,
yeah.
But the goal is to look and feel.
Mm-hmm. Yeah. Right. Which is fine. And then let's see, just keeping on with the Federation, we're basically trying to grow the group. One of the things that they've got on the East Coast, so the Vintage Computer Federation has a brick and mortar museum in Wall, New Jersey. I didn't bring any pictures of that, but you can go and look it up online. We've got a ton of fun stuff. I mean, they've got a bunch of PDP equipment and all sorts of different PCs. We've got a running UNIVAC now. And a really nice setup. I mean, if you're not able to get out to the out to the Computer History Museum, sorry, you know, because you're stuck all the way on the East Coast, it's a good second. So they've got that, and because they've got a space and a presence there, they've actually got the ability to do things like workshops, host meetings like this, and basically get a number of geek groups together over different topics to build the community and keep people interactive and to sort of farm for exhibits and volunteers and whatever else for the VCF East. I'm looking to do something similar for the West Coast. Really like to get an active community, a general active community of vintage enthusiasts out here to do exactly what I just described, to do workshops. I mean, they do stuff like every once in a while, people bring in a bunch of dead power supplies that they've got for some of their vintage machines because there's one guy that's pretty good with analog power supplies, and they'll just diagnose and fix them on the spot. Or displays. They've brought in old tube monitors, and people have worked on getting those things running again. So just simple workshops on how to do stuff, and a group of 6 or 8 or 10 guys will get together in one of the rooms near the museum and do the work. So probably similar to what you guys do here, but you know, more periodically, more intermittent. So if anyone is interested in doing that kind of stuff on the left coast, I'm looking forward to setting stuff like that up, getting a local sort of meta user group of vintage enthusiasts together and organizing regular events, whether it be workshops or attendance at Maker Faire or helping out at VCF or whatever else we can come up with. One of the ideas I like to keep floating, only because it keeps the rest of the board members every time I do it, is I want to build a bus. And by that I mean I want to take an old school bus, convert it into a rolling museum, stuff a bunch of my collection in it, and drive it from school to school and let kids do on-prem field trips into the bus to see old technology. The guys on the board still think I'm joking. I really do want to do that. In order to, however, I'd have to do some fundraising, and I'd have to have some volunteers that are willing to go in and rip the bus apart and put it back together again with electricity and whatever else we need. So, just a thought.
The weird stuff warehouse double-decker bus is no more.
Yep. And Halted. Anyway, so that's pretty much all there is about the Federation. You know, I'm willing to take whatever questions you might have, but the overall, obviously, goal of the group is to evangelize this vintage hobby and to get more people excited about it and to bring nostalgia to happy families everywhere. I think, you know, one of my favorite things at Maker Faire is watching moms and dads show their kids stuff that is 10 times as old as the kids, and the kids are still enthralled.
And what you're saying is you can actually bring, like, because see, I have an IBM PC Model B, and the problem is my monitor doesn't work. But you're saying these guys can actually fix those things?
Yeah. I mean, we got local guys here that do the same stuff. I actually, I had donated an IBM PC 18 with an EGA monitor, an IBM EGA monitor, to the Computer History Museum for use in one of their displays and demos. And I was standing in the lobby doing a public event one day, and people were working on that monitor or working on that system with the monitor running, and all of a sudden, you know, people started oohing and ahhing because smoke started pouring out the top of the monitor. Everyone here has had the magic smoke, I know it.
It's got that distinctive odor.
It's got the distinctive odor, and of course I was right next to the cafe, which they loved. And sure enough, you know, we'd blown one of the filter caps on the main power board, shut it down, put it away, and one of our local guys, he's actually on the PDP-1 Resto team, also at the museum, took it home over a weekend and repaired it. So recapped a good chunk of the monitor for us. But yeah, I mean, that's the kind of thing I'd love to do. We need to get crazy enthusiastic people, space, and then some organizers, people to drive specific events for either workshops or different sub-interest groups or whatever else. And I know we've got the talent. I mean, I know a bunch of people out here that I can ask for help on anything from rebuilding an Altair front panel to, you know, recapping a Mac 2 CX to whatever else.
HCR33s?
So, yeah, so you'll... Yep.
or 5 of them there. And you can see the Reuters feed spooling off the, that page, Reuters feed. What?
Yeah. Yeah, I know, when I was undergraduate, they had ASR 33s in the observatory, to record photometric data.
So, since we're talking about it already, we'll keep going with the VCF West. So VCF West was, month hasn't changed yet, so it was early in the month. A few weeks ago, I'm still barely recovered, you can tell. We had a great show this year. We had, I can't remember, it was about almost 30 different exhibits, covering almost 50 tables. I had probably 8 speakers over the course of 2 days, plus a couple of classes over the course of 2 days, to bring people in and look through. And I'll show the pictures, but the exhibits were everything from the guys that were restoring teletypes of various vintages, so ASR 33s, 15 else. We had a lady right next to them that had an old weaving machine, an old loom, that was controlled by an early 80s computer. She'd bring up a pattern on the computer and she could print it out on the loom, so it was actually, quote, printed on cloth. Basically. So, and I've got a picture of it up there, and then on top of that we had, all sorts of stuff in between. So we had guys there that were showing off a bunch of rare Japanese computers, for instance. And the other guy was a big aficionado of the original adventure game, the Crothers and Woods adventure game. And he brings his original IBM PC every year and lets people play adventure and, get LAMP and whatever else on an original machine. Playing at Faux. So, ton of other stuff. I can show you the pictures as we go. One of the other things we have, and that's what the picture behind me is we do a consignment area every year. So consignment is just a way of clearing out your garage and filling up someone else's so that you have room to go and buy stuff there and fill up yours again. Right? So this year we moved the consignment off to a separate area. So this is one of the classrooms at the museum. And we absolutely packed it chock full of old stuff that changed hands. And the Federation takes a small cut. That's part of our fundraising from this event. And people have a ball pawing through all this stuff.
You can actually go in there and sell your old stuff.
Yeah, you can bring in, even if you don't pay for attendance in the show, you can bring in piles of stuff to this space. You got to fill out the paperwork and put prices on it. And then we run the front desk. Jeff there is at our front desk, and we'll sell the stuff on your behalf over the course of the weekend. When the weekend closes, you get the money for what you sold, and you get to take home what you didn't sell.
Must take home.
Exactly. You can't leave junk behind. And people have been doing a really good job of that. I haven't had too much stuff left behind, and most of it's been just little bits and pieces of junk. So we've got the consignment area. This is one of our big sellers in the consignment area. The gentleman in the reddish shirt is Salam Ismail. And I point him out only because he is the founder of the Vintage Computer Festival.
I think he spoke at one of our board meetings.
He may have.
He may have, yeah. The name sounds familiar, right?
Yep. Yep, he's probably a fourth geek as well. He's definitely into vintage computers. He, at one time, had the largest collection on the planet, privately owned.
Because he got all my magazines.
He got a lot of stuff from a lot of people. He's the one that ended up turning over the IP for the whole VCF and related stuff to us. So now he's just a seller, and he's getting rid of the I wouldn't say last vestiges. He's getting rid of parts of his collection year by year, and usually takes up about a quarter of our consignment space. Anyway, just as we go through, if I see anything interesting, I'll point it out. These are just the pictures that we posted online of the show. Let me know if I'm in your way. Which is some of the displays that we had. And this is the kind of thing that we usually expect. People will take a table or two or three and pull out their favorite stuff, and hopefully... Do I get a laser pointer on this?
Yeah, it's the green button.
That green button.
No.
Here. I just turned it off.
Here that's green.
Oh, that green.
Okay.
All right. Well, and I'm not even colorblind. So
Your green receptors are overdriven by your shirt. So.
that might be it. That's it. So anyway, the things that I like to look for, and we actually do judge exhibits every year. I'm not one of the judges because that would be an overload of epic proportions. But you saw Chris Garcia, who's the software curator at the Computer History Museum. He runs the judging crew, and he sets the criteria and whatever else. And they look for things like display quality and document quality, and then of course the running state of the machines and what you're demonstrating and how much you know about it and so on. So we're always looking for things like poster boards and working machines and lots of peripherals and lots of examples of why this machine was cool in the day. So like these are some of the guys that were showing off some of the old Japanese computers I mentioned before. That's our Monster 6502 running chess, an Apple II version of chess from back in the day. And the Piney P8s, and I don't remember what these guys are doing. I think I could look that up. Oh. No, these are Altair. So this is an Arduino Altair and an Arduino CAN back, which
Altair Arduino.
Yep. And they're very cool because he, it's just a little thin box that's got the full front panel with the switches and lights. But he's pumped everything in there. So it basically boots up to CPM, it boots up to Altair Basic, and he can, you can run stuff off of a little SD card. There's a whole ton of old HP equipment. And by ton, I mean hours to chuck that stuff in. And speaking of which, when I get to it, these are some more of the rare Japanese machines. We had a rack brought in, so 2 racks and a bunch of stuff.
I remember that middle terminal. That's a VT100.
It is, yeah. Did he ever get it to boot?
He eventually got it to boot, like right toward the end. When he brought it in, it was
watch him running diagnostics and popping boards out, and it was great fun.
Oh man,
yeah.
Just like the olden days.
I remember that VT100 because it had this novel feature. It had a separate keyboard. Because before that, we were using Hazeltines.
Yep, and
it was all together, so
yep.
You literally had to move the whole thing to your comfort zone.
Yep.
Oh, God. And 9,600 baud.
Oh, if you could get it.
Oh yeah, well yeah, yeah.
So I remember they had the LA30s and the LA120s, and the 30s were 300 baud, and the LA120s were 1,200 baud.
I remember that from college.
Yeah. Anyway, this is our teletypes crew, and that was the loom. So you can see the device in the front right there on that is controlled by an old computer. And actually weaves the different patterns. She wove our logo, the Vintage Computer Federation logo, on cloth, which was amazing. And yeah, some more little craziness. Atari user group has virtually everything that you could imagine Atari branded. Just some overview shots, and then we'll get to some of the speakers we had.
I was there at this one just a few weeks ago, and you had an Apple I.
Yes.
There.
So.
Whoa. I saw that right when you first come in.
Yep.
And I didn't recognize that particular one, but how many of those Apple ones still exist that you know of?
Estimates are somewhere in the 50 range, plus or minus.
50?
Yeah, maybe.
Holy mackerel, because there are only 200 made.
There were actually, I think there were more than 300 made. There were 200 made for that first run over at Byte Shop. And then they made a few more after that, but they recalled them all because anyone who wanted to could turn in an Apple I for an Apple II for a discount.
Yeah, that was the thing. It was $666.66.
Yep.
For an Apple I, and because I bought one. And one of the biggest mistakes I made was to turn it in to get my $666 back on an Apple II.
Yep. And back in the day, Woz used to have a box. He used to have a crate in his office, Apple, with Apple One boards, just stacks of Apple One boards. He'd go and pirate parts off of them. So if he was doing a little project and he needed some ICs, he'd grab them off of some of his Apple One boards. A couple of guys that worked for Apple back in the day asked him if they could take a couple home. And he was like, yeah, sure, take them. And they ended up selling those for hundreds of thousands of dollars, a couple decades later.
I heard $1.25 million was the last I heard price for one.
I haven't heard that one yet. The last one I heard sell, or the highest one I heard sell, was a little under $1 million. And the lady that was showing the Apple One that was on display was the person who entered the bid on that machine. So she works for an Italian guy who's a clothing magnate, designer or whatever else in Italy. And he's also in old computers. So he has hired her as the curator of his traveling museum. So Cecilia runs around the world showing off some of his toys. And he owns 2 Apple Ones, the one that was on display and then the more expensive one, both running.
Do you have a lot more?
I'm out of time.
Ish, yeah.
Okay, sorry about that. I don't even need to mention them, but I will point out Cecilia was one of our speakers. You already mentioned Bob Zeidman, who talked about things like software rights and such. But the speakers are a big part of the day, and we get some really fascinating folks. For instance, the gentleman who wrote DOS basically for IBM, the DOS that IBM bought for 50 grand and sold off to, or leased off to IBM. Anyhow, I think that more than covers it. As usual, getting me to shut up's the hard part. If you got any questions, I'm more than happy to stick around and answer those. But I don't want to take you off schedule.
Thank you very much, Eric.
Thank you. If you have that one.
Great.
Oh, yes.
Does anybody need a bathroom break? Okay.
Everybody ready?
I'm ready.
Okay. So Kevin requested that I take some pictures at the electronics flea market a couple months ago because somebody who wasn't in this area was interested in the flea market and was requesting some pictures. So that's how it started. So this is in June, and now they have these flea markets on the second Saturday of the month, and now it's at Fry's this year, the one in Sunnyvale. And so here I am approaching the sort of the south end of the building over here, and it's it takes up these 2 aisles on this side. There's tables on both sides on 2 aisles. That's the extent of it. So it's maybe a little bit smaller than previous years, but a lot of the same people and products there. So it's a typical table. See a bunch of stuff, and the stuff can range from like test equipment, ham radio equipment, old meters, books, ham radios, all sorts of stuff. So you just have to go to all these tables and see what they have and see if there's anything you might want to grab. So this is like a electronic drum set, I think. Here's like a bin of tubes, and there's always a couple guys selling, just tubes, and there's another guy that sells just soldering irons and stuff like that. So there's flashing light stuff. There's hardware in bags, transformers.
Not the Megan Fox kind either.
Yeah, so this is a bunch of cameras and stuff. I don't know where these guys get this stuff. I hate to think that some of it might be stolen, but yeah, whatever. It's a little mixer. Let's see. Oh yeah, some old cameras.
I always
Oh yeah,
going into a Goodwill store where the IKEA stuff is more expensive at Goodwill than it is at IKEA.
Yeah. Camera stuff. And here's a guy that's
pottery and stuff, tableware.
You done? So here's a guy that sells all these hardware items, and he's there every month. A lot of bungee cords and stuff like that. So bungee cords. Test equipment. I don't know how competitively these things are priced, but I imagine this stuff is in the hundreds of dollars. Some people might really want to get rid of things and not take it home, and they'll price it a lot lower for sale.
And lower as the day goes by.
Yeah. So even music, there's several people that sell vinyl and CDs and stuff like that. So old ham radio stuff and meters, power supplies, microscopes for looking at ICs, I guess.
Yes.
Yeah. Tanks of oxygen. Green is oxygen.
Yes.
Yes, we know that. So more. This is Tektronix stuff over here. This is HP stuff. Golf balls and tubes. It's just, if you're looking for something, you'll find there's a bunch of CD-ROMs and old laptops, I guess it looks like. Remote controls for TVs. And this is, well, I'm not sure his car is for sale, but I just wanted to show you the setup where, you pay like $40, sellers to pay $40 and they get a parking space, and they get an empty parking space to put your stuff in. So, and then some people label prices on their things, and other people you have to negotiate. So, more ham radio stuff. Yeah. Toys. Monitors, computers. Again, records. Old tape recorder. I remember this stuff. Slide projector.
Timing light.
Yeah, timing light gun, yeah. Meter in a wooden box. A barometer, yeah. Old film projector.
It's like a 16 millimeter.
Yeah. Yeah. Yeah, in a real nice box, felt lined box and everything. Looked in pretty good shape. Again, more ham radio stuff, speakers, cameras. So a lot of guys, specialize in one item. Yeah. Camera. QST. Who got QST when they were a kid? Yeah. Yeah. Books. Musical instruments.
really useful. No electronics.
This is all, I think this is all records. Yeah. Yeah.
That's in the days when cover art actually was something.
Right.
You can actually look at.
Yeah.
Now it's just a little tiny.
It's a thumbnail.
Yeah.
On Apple iTunes.
There's a lot of other places that sell records. There's several stores. If you're interested, that's
Barnes and Noble has
right.
a whole section.
Yeah, but yeah, right. So yeah, so vinyl is having a resurgence.
They started making them again.
Yeah. They're not as cheap as they used to be. I remember buying a record back in college for like $3.50 for a new record.
That was a lot of money back then.
Yeah. And I think they go for about 10 times that, $20 or $30 for an album
they
now.
had to kill the sheep you didn't develop and put the money on it.
Bluetooth keyboards. These are like chords and stuff. I think these are just
Different type of cord.
chords, yeah. Magnifying glass. Oh, ferric chloride. Who knows what ferric chloride is used for?
That's your copper printed circuit
That's
boards.
right. Okay, you guys got it.
Anybody know how to make ferric chloride?
No.
Yeah, the one guy here.
No. Create chlorine gas, from chlorine cleaner and bleach. Put it into a large, container, and then take steel wool, heat it up, and plunge it in there into the chlorine, and you'll make ferric chloride.
Yep.
Thank you.
I learned that when I was 8 years old. The Golden Book of Chemistry is where I learned my chemistry. It even showed how to do it.
I was going to say, that sounds like a Boy Scout thing.
Yeah, well, I never was a Boy Scout.
Burning magnesium and carbon dioxide.
It's take a hanger, cut it off, and it had a little hook on the end. You just heat it up, and then just plunge it in. It reacts. Yep.
Okay.
Wow. Yeah.
Moving on.
Yeah.
More USB cords. There's a whole table basically of cords that you can buy. And here's the other end of the table.
I didn't see that one.
Yeah. These are mice and external battery packs. Not very good prices on the external battery packs. This is a seismometer. Size. Yeah. So I don't know if you guys know, but Marantz was really big in hi-fi, and this is one of their tuners that was like a top of the line tuner. Yeah. Old laptops, out of focus stuff. This was a guy selling these electronics modules. Yeah. Old radios. Yeah. Multi-band. So Zenith made a bunch of these, and I actually worked for Zenith a few summers back in Chicago. Yeah. The quality goes in before the name falls off. So I was there at Zenith before they did anything with circuit boards, and so they had like hand soldered, hand wiring. So they used that as an advertising feature, hand wired, hand soldered. Okay.
Soldering iron, literally with big
Yeah.
beefy.
Yeah. Oh yeah.
Copper.
Yeah.
Did they not even have boards, perforated boards?
No, they had like terminal strips that you put the end of the component into, and then when all the parts were in, they fill it up with solder.
There were some old Tektronix scopes that had porcelain with silver inserts.
Yeah.
And in order to work on them, you needed special solder. So when they manufactured them, the last thing they did was roll up big piece of the solder and stick it in there in the chassis. So when you had to fix it, you had some solder.
Yeah, they used to put extra radiant paint in those antique cars. Remember the radioactive Boy Scout looking up?
Yeah, Geiger counter. So you'll find almost anything at these flea markets, you know, fire truck. So all the stuff over here, these are all CDs, and I went through them all in June. This last time, he only had half as many, thank goodness. But you know, he's a guy that sells a lot of books and DVDs and stuff like that. So he's got a pretty good collection. And these were like 3 CDs were going for typically the guys that really want to get rid of used music CDs, some for about $1. And guys that have a collection like this, they're maybe a couple dollars or 3 for $5, like this guy. But you know, you can take a look at the media and see if they're good or all scratched up and make your choice. So, yeah, what is this? Nuts and bolts and stuff. So, you know, some people sell stuff right out of the back of their truck, and this is ham radio stuff, soldering iron back here, you know, U-boats. Yeah, so, I mean, yeah. Yeah. Hellcrafters, old ham radio stuff. Yeah, I had a Hellcrafters setup for a ham radio when I was in high school. Dual turntable. I have a dual turntable like this. Yeah, nice, neat stuff. Tube tester. I remember people a tube tester in yeah, right. Yeah, that was cool. Watches, whole bin of watches. It's just crazy. Speakers, motorcycle, another old AM radio before FM. More albums. These are a little bit more beat up, so they're probably like cheaper, probably like $1 a piece. Miscellaneous. It's a little bit bigger, yeah. Again, more cameras and microphones. So this is there's usually a sponsor for each one of these monthly, and they have their own table. Typically, it's a ham radio group, and so they sell soda and donuts and stuff like that. Another film projector, just a bunch of stuff. Some of the stuff, you know, is really organized, and some is just like in boxes, miscellaneous stuff. So if you want to get down on your hands and knees and scrounge through all these boxes, you know, there's an opportunity, but, you know, that's not what I do anymore. You know, more ham radio stuff, another Zenith radio, another Fair. This is a really old antique radio that was in pretty good shape. And this is 45s. This guy was selling 45s. And that's it. So I have another set of photos from the Vintage Computer Festival. And they're sort of similar to yours, but I focus more on the hardware than the people. So if you want to see those, I can do that, or we can. Yeah. So Kevin's shaking his head. What? There's second Saturday of the month, and the last one will be in September, and it's at Fry's in Sunnyvale, and it's free. Parking is free and whatever.
Oh, is it more kind of like the original?
Yeah.
Fry's.
So it used to be. No, it's in Sunnyvale.
It's nearby. Yeah.
It's right adjacent to the building. So it used to be held at De Anza College in previous years. It was at Lockheed parking lot one year, and it was at Foothill College for a number of years as well. So, but it's the same stuff.
Yeah, I think Foothill kind of priced it out of the market.
Yeah.
Did they want money for security and cleanup and all that stuff.
Yeah, you paid $3 for parking too.
Yeah, very few people actually pay all $3. You know, they would sell their parking tickets to someone else, even though they were not transferable. That may have pissed off the school as well, that they weren't making as much money as they wanted to from the parking. Screw you otherwise.
So I'll go through these pretty quickly since you've probably all seen these all before. So I just got there, you know, really early and went through all the tables, and I'm not sure I know a lot about each specific table, but you know, Atari.
They had all sorts of rare stuff, some prototype.
Yeah, so this looks like an Apple II, right?
And I think their big thing was were they the ones that had the speech chip prototype?
I'm not sure. Oh, this was. I always find this interesting. You know, there's this vendor that has a table of old media, so they have like one of every type of media that you might have ever seen. You know, so all these recording medias and stuff like that. It's really interesting, and they said that that some of them were write once media, and essentially had a kind of encryption that sort of reminded me of blockchain. So that they knew exactly what was on it and who put it on there and when they put it on there. But you remember old zip drives and 8-inch floppies, 5 1/4-inch floppies, 3 1/2-inch floppies.
Yeah,
a lot of
DVD that had a special arrangement. It had its own player, and you could rent the DVD, and it would stop working after a while unless you paid money to buy it, and you'd get a code.
Yeah.
Then you could watch it forever.
Right.
Until your player broke.
Yeah. So the idea was you can play it 3 times for free, and then you had to buy it.
Well, it wasn't free. You paid to rent it.
Okay. Don't copy that floppy.
Oh, God.
Special shapes of CDs. Floppy disk was hole punching. That Shania Twainer thing was don't play it in your computer disk. It'll spin too fast and it'll be out of balance.
Yeah, so I found that sort of neat.
Or places where on the floppy it would have been laser.
Anything for errors in the right, just the right places.
Ooh, that's that.
Um,
Apple One. Wow.
See, it's one.
Oh yeah, it's inside the box. Old chess computers. Texas Instrument. Oh, so this was really interesting for me because I had one of these computers. So it was these board with these 6 wheels on it, and you'd wire it up in the back and turn the wheels, and things would light up. And I remember I tried to wire it up for the tic-tac-toe game, and it really never worked right because it didn't make all the contacts really well. But I remember I had this for one summer, and someplace I still have all the hardware, but so this was resurrected. So this brought back a lot of memories for me. So it's called the Geniac. And these are other computer board games, computer kits from way back. Other computer stuff. These are add-ins for Apple II.
Contemporary now hardware for old computers.
Right. Apple II GS?
No.
FC, Apple IIc, right. Yeah, Apple stuff. Here's that another view of that Loom, and apparently, so on this one, you had to move this thing back and forth manually. Shuttle. And, but the woman told me they have automated versions of this, so that will have a robot hand do it. Teletypes, that brought me back. Yeah, so this is the Model 33, ASR 33. I had one of these, and this is the paper tape reader and punch over here, and all sorts of mechanics in there. And this had a distinctive smell of oil and distinctive sounds. And this is my first, terminal. There is a way you can convert this to 20 milliamp current loop, which you can. I had an I/O board for my Altair that would accept this. So that was my first terminal, and I played with BASIC with this.
And if you've ever wondered why VI has weird key combinations for cursor movement, look at the H, J, K, and L keys on that chart.
Yeah. So there's no lowercase, in case you didn't know.
Yes, that's right.
Yeah, no lowercase.
Shift key for that.
Well, no, I never saw it print lowercase. Yeah. Yeah, so this is like 110 baud and 300 baud, or
110, 300.
yeah,
That's
right.
about right.
Yeah.
Actually, it's more like probably 75 and 110.
Yeah. Yeah, so this is what it looked like with the case on it. So it had this roll paper and the paper tape over here, and then there was some, you turned on various things over.
In later models, on the right-hand side is where they had an acoustical coupler.
That's right, right over here. Yeah, I didn't have that on mine. I built my own.
Yeah, that was one of the options that you had for them. They had either they put in the pedestal, a big old modem setup. I had one of those for a long time, or get acoustic coupler built into the sides of that panel.
Right.
Come off of that.
Right.
Either controls on it or some of the other stuff we did, or
Yeah.
a bunch of options.
Yep.
It was in the days when it was much more restrictive about what you could hook up to the phone line.
Right.
Oh, yeah,
That's why they had, yeah.
That's why you needed acoustic couplers.
Yeah. So this is an older model, Model 15 teletype. Sort of worked the same way, but it was much bigger. Original IBM PC.
Running Adventure.
Oh yeah. VT100, I think. Yeah. Deck writer. I forgot what this board was. To see, it's missing keys.
That might be the Australian
Yeah.
computer of the Apple II sort.
New brain. This is Atari. Yeah, Japanese computers, TI computer, Timex Sinclair, which was a Z80. Yeah, they actually had a fourth for that, I know. Yeah. Whoops. Game computers. Digital Group, that was big when I was going. Yeah. And yeah, they had lots of boards in here, and there's a train set up. But you know what? With this Digital Group, they had over here, they had these computer-controlled cassettes, FIDEC, and so they had two of them there, and it was just basically like a floppy disk, but on long tapes. So you can actually do a directory DIR and go rewind all the way back to the front and print out the directory, and then you'd be able to transfer files from one to another, but it took so long.
I think it was called, instead of DOS, it was called COS.
Yeah.
Tape operators.
Yeah. Yeah.
It's like the Exotron stream.
Right. Yeah. Yeah, I have one of these. It's a little DOS machine, handheld DOS machine with a serial port. So, no, this was not this one.
Oh, this is earlier than the WinC.
Yeah.
This only has a monstrous 1 megabyte of RAM.
Right, and I think there's a couple.
Back in those days.
Yeah, and there's a couple cards that you plugged in here, memory cards that were about a meg each. This is back toward the front. Yeah, these are Altair front panels, and I had an Altair.
Altair Duo.
Yeah, so this is pretty interesting. And they did a pretty faithful representation of what the front panel looked like. Yeah, so this brought back a lot of memories too. So there's the front panel, all these switches that he had to solder in, and all these LEDs and stuff like that. And right. So this is a little computer and display here that he had running. Let's see a bunch of other. Oh, getting back to PDP-11 stuff. This is, what is this? I can't read that.
I recognize that, but I can't remember what it is.
Oh yeah, this is the CPU-less computer.
TTL microcomputer RAM.
Yeah, this thing is built entirely with TTL.
Wow, neat. Cactus computer. An old ADM3. I had one of those. Yeah, I remember doing that too.
Straight off the Vintage Computer Festival T-shirt.
Oh, televideo, right?
Close enough.
Yeah.
There's the 6.5.
Yeah. Again, more computer games. Four channel sound card. It's maybe for Apple. Apple II. So this is in the consignment room, and there's this guy selling a bunch of slide rules, and I think this is the one that Kevin bought, right?
Yes, I did. I had a
That
friend at work who wanted a slide rule. And that's what I want to say $40. It was in very good condition.
Yeah.
It was a perfectly smooth, nice wooden slide rule. And buying those on eBay is a mug's game. You really have to be able to hold it in your hands and say, okay, this is the one that's not bent, and it slides smoothly, it's not got any burrs on it, the cursor's in one piece, it's not got a lot of scratches, all this stuff,
Yeah.
If you want a nice one, I don't recommend eBay like that.
So these are disk platters, and here's a hard disk drive, and some memorabilia.
When the disc was sealed.
Yes.
I can remember one where you pulled out multi-platter, like.
Yeah, there's cartridges. There's
they were
cartridges.
like, 18 inches across.
With a big one in the back there. Yeah. You get about 5 megabytes of data, 10 platter,
Right.
10 megabytes of data.
We had one with our computer work that was the size of a washing machine. That had a removable 1 gigabyte platter, which was really
Gigabyte?
gigabyte. Yeah, it was good.
That's
It was the size of a giant cake,
In 1973, when I was working for ISS, we had an ad, which was a picture sort of like an Apple ad, all white background, and it was big, large refrigerator-sized box.
Yeah.
That was a controller. Then 8 washing machine-sized boxes, and the big thing on the ad was 200 megabytes for under $200,000.
Well, we used to call these Winchester drives.
Yep, they were.
Do you know why?
Because they were a mystery.
Well,
No.
no. No, because it was a fixed 30 megabyte drive with a 30 megabyte.
Oh,
No, really.
I believe you.
This is.
I don't get the joke.
Okay, there's a rifle of that caliber.
So here's some of these removable disc packs. Here's a,
Yes.
yeah.
That's the one.
Yeah.
That's the one I was talking about.
Yeah.
That's the Calcom.
Yeah.
10 high pack.
Yeah, right. And so there's 10 platters in here, and there's this thing that you grab as a handle and you screw it down to load it.
And then take the cover off.
Yeah.
Close the lid.
So this is a Model 100 Radio Shack. I had the NEC version of this. This had a 8085 computer in it and 4 lines of 16 characters, and it had a built-in modem and serial port and stuff like that, and it was like $600, I recall.
Yeah,
So,
until about 4 or 5 years ago, I think there were actual reporters that would
yeah,
use these to write their stories and phone them into the paper,
yeah,
the newspaper, back when they were still newspapers.
yeah. So this is a Atari Portfolio. I used one of
New York
these.
Times was a former newspaper.
Yeah. Sort of much smaller than the Model 100. But again, it had a serial port, so if you had a serial port, then you can hook it up to an external modem and stuff like that and actually get things done. And I think this had DOS on it as well. So this is an H89. I had one of these too. This one actually has a hard drive in it, which required a special card. But it came with one floppy. But I found that DEC made a dual floppy with one spindle. So it had 2 slots, and so it was an A and B drive. And to insert the floppy, you do it one way on the left side and have to turn it over on the other to do it on the other side. So the label faced out on each side. And I had to rewrite the system because if you move the head on one drive, it moved the head on the other drive, and normally those are separate drives with separate track information. So I had to consolidate that. So yeah, God, I remember that. This is a
It's like K-Pro?
K-Pro device with 2 floppies, a bunch of S100 boards, inch drive.
In the sales area.
Yeah, this is all consignment area. There's
Osborne.
Yeah.
Osborne Executive.
Yeah. So another H89 and with a single floppy. Yeah.
A portable computer.
Yeah. So the thing to notice is circuit boards above and below.
8-inch.
Okay, so these are Zilog computers, and I had these at the VA, and it was a Z80 computer, and these were hard sectored floppy disks, and there was actually a guy who made a ROM that converted it into CPM. So I used this for a number of years, and it worked out pretty well. We had about 6 of these at the VA that were donated by Zilog. This is an Otrona. We had one of these at the VA as well. It's very nice, very small, compact CPM machine with a nice built-in orange video tube. Worked out really nice.
I was told that one time that the floppy disk was the original floppies were invented, 8-inch ones anyway, for the IBM 370.
Right.
That is, they were the bootloader.
Right.
Inside
IPL.
Yeah.
Actually, not even the bootloader. What it was is
The
that's when you
updates.
downloaded microcode to the processor.
Yeah.
Oh, right.
Yeah,
Right. Oh, that's right. And then the IPL would be.
And then it would boot off a channel 0.
Yes, off of a punch cards.
Yeah.
Yeah.
Giant deck.
It's old.
Where IPL used to take like an hour.
That was the breadboard. Just to load.
Yeah, this
Yeah.
is loaded on with 360. I remember at Telcom they had one. We had tone terminals, and they always said about every minute run your stuff out to the computer. Make sure you do that because that 360 was notorious for crashing.
There's a reason for that.
Yes.
So floppies came from that 8-inch
Right.
design.
This is a breadboard, Heathkit breadboard. I'm not sure what computer's on this one, but he had a chance to, line up LEDs and program and stuff like that.
Sim 1.
Sim 1, yeah.
6502 single board computer, onboard ROM monitor.
Yeah. Some old
RAM chips for 1K by 4 bits, so you needed 2 chips to make a byte.
So old Windows machines, probably an H19 terminal. Yeah, I built about 6 of these from kits, and that's about it. So, thank you.
So I've got, I don't know, 2 sort of hobbyish projects at the moment. One of them is trying to either write my own bootloader in Forth or understand how existing ones work a little bit better. I've, I don't know, managed to go through a couple of tutorials and write really crappy ones in assembly and get those to print things inside Qemu. So that's about how far I've gotten on that. And the other thing that I kind of want to try to do is write a statically typed concatenative language with operations that generalize to arrays and streams in sort of the obvious way. Okay, that's
so
about
one
it.
of the things Greg talked about was the tool chain to write open boot stuff or open firmware if you don't want to infringe on Sun's trademark. So That guy wrote open boot stuff at Apple back in the John Hall era of open firmware. And Mitch Bradley sometimes used to show up at these shindigs. Mm-hmm. So if you want to work on a project to make an environment in which to write open boot-ish type stuff, that might be an interesting thing to move forward with. One of the things I wanted to mention at Rumors, Gossip, Slander, and Libel was 4th Day is a coming. So,
November?
in November.
3rd of November. 3rd Saturday in November.
Yes. Some of us had a problem remembering that it wasn't the 4th Saturday in November.
Yes.
So, if you want to present on 4th Day, you're more than welcome. And in fact, now's the time to start thinking about what you're going to present on 4th Day. Sam? So,
Greg?
you're going to be presenting
We're
that.
considering bootloaders. Have you ever looked at U-Boot? U-Boot. U-B-O-O-T.
But it's oh wait,
It's DOS U-Boot.
Okay, thanks.
DOS
So it's the same thing. Okay.
Yeah.
All right.
Yeah, it's one, it's more, U-Boot is more ubiquitous.
I've used it to try to bring up an XOS system before, but that was years ago, and I had no idea what it was doing. NixOS. It's a Linux distribution with a functional package.
How many people learned Nix using Mixall? Okay.
Wait, is that the assembly language?
It was sort of a processor agnostic assembly language called Mixall.
I've heard of it.
And it was the way that in the olden days, it was the way you taught people to program, because you could write a mix emulator that would run on any number of machines. Students could write language and debug it without having actual piece of hardware on which to run it.
Yeah, it's Donald Knuth's thing for Art of Computer Programming. And he's refined, in the latest revision of Art of Computer, it's now MMIX, the minimal architecture, because it's all RISC. It's MMIX. Yeah.
It was named after a movie actor named There's this guy from Texas, believe it or not, that started all of this.
You were talking about writing a statically typed first.
Yeah, statically typed, right.
Free-based cat-based language.
Yes.
I'm interested in that too. Have you looked at Lane 5? It's sort of similar. Array-based cat-based language.
I haven't seen that. I should check that out.
So if you're feeling creative and you don't want to do this stuff, I'm looking for starting comments to put in that portion of the agenda that says, we don't really pay a lot of attention to the schedule, but speaking of the schedule, we're needing another thought about SVFIG t-shirts. If Brad is going to make them in time for 4th Day. So think about that. And while you're thinking about that, we're into Sam's time.
Indeed.
So Sam,
One other thing, you want to just sign up on the mailing list.
Okay.
You can, submit questions to.
yeah. How many people are not on mailing list? Show of hands. Okay. At the break, you want to see that guy. He's the chairman for life. Current dictators for life? Well, Chairman George.
I tell you, I was dictator for life, but Red China has given dictators a bad one.
Well, that's what I was thinking about pirates. I used to rejoice every year and talk like a pirate day. And then, modern day pirates are just too wild to see.
Sam, it's all you.
Not like
Farmer
we have.
Sam wants to give his talk.
All right.
Thank you for your patience, Sam.
No worries. So this is a preview or a test run, if you will, of a talk that I want to give on fourth day. As you may recall, previously on fourth day, I gave a talk on declarative, inquisitive, then imperative programming style for fourth. Aesthetic programming is something that evolves out of that. In much the same way that extreme programming evolves out of test-driven development, for example. And I got into thinking about aesthetic programming after reviewing my equilibrium sources again. So if you may recall from many years ago, Equilibrium was a video game that I wrote, which I wrote using aesthetic programming techniques. So what is aesthetic programming? Well, we should look at the definition of aesthetic first. And according to Google, basically characterized by or suggesting the practice of severe self-discipline and abstention from all forms of indulgence. And I would like to focus on each of the bold-faced items there. First, let's look at self-discipline. Fourth, as a programming language as well as an environment, is often described as not being a bondage and discipline language like Pascal or something like that. But it says nothing about your self-discipline. You have to have an incredible amount of self-discipline in order to get fourth code to work right. And just anyone who's ever written 00 bang at an OK prompt will know exactly what I'm talking about. Right? In most cases, that will happily crash your fourth environment. Fourth will let you do this even more easily than C code will. C code at least requires you to have typecasts in order to express that intention. Whereas fourth does absolutely nothing whatsoever to prevent you from doing stuff like that. It's a very libertarian language. And being libertarian, discipline becomes even more important when you're dealing with other types of program defects. I mean, how many times when using Gforth, arguably one of the most memory protected of all the fourth environments available, how many times have you just thoroughly corrupted your dictionary while you're in the midst of development? It happens all the damn time for me. It's quite frequent. And by corrupt, I mean to the point where you can't even use by to exit out to the shell. You have to open up another shell, issue a kill-9 on the process to actually terminate it, and then relaunch it. So when we're working with fourth, it's not a matter of how the dictionary got corrupted. It's a matter of why you let it happen in the first place. Fourth puts that responsibility on you exclusively. So there's a lot of self-discipline that goes into fourth development. The second thing I'd like to point out is the focus on indulgences. And this in turn can be broken up into two separate things, both language and runtime. I'll start with the runtime first because it's what more people are familiar with. In particular, I'm talking about object-oriented programming. It's everywhere today. OOP is literally lingua franca for every enterprise, scientific, financial, or even deep embedded application these days. But what actually is it? It's basically a way of thinking about software components and how they interact with each other anthropomorphically, essentially. You basically anthropomorphize how the software works. You have these little units of software which conceptually are operating independently of each other. And when you want one object to communicate with another object, you invoke a method, which is not technically correct. You're actually sending a message. The message is the name of the functionality you want to reference, and the method is the actual concrete implementation that gets run. You can read more about this. Dr. Alan Kay has written
profusely about this, especially when he coined the term object-oriented. There's an essay online that you can read about what was in his mind at the time. He actually regrets calling it object-oriented programming. He actually meant to imply that it was message-oriented. The other indulgence is on the language side. So especially with respect to Forth, if you're going to be doing object-oriented programming, you almost certainly are going to involve an additional package which extends the language syntax and possibly even semantics to include object dispatch and things of that nature. There are some consequences about this, one being that it consumes more memory than you want. For example, what if I want to integrate a program written with GForth's OOF package with something from SwiftForth, which was written in their specific object-oriented notation. MPE Forth has their own specific implementation. And if you want to integrate these three things, you can certainly do it. There's no question about it. But in your delivered executable, you've got three object packages. Why? It's just a bunch of redundancy. So there's a lot of indulgences that can be removed from your programming process, if you will. So let's go ahead and look at what ascetic programming itself involves, right? So here's my definition of ascetic programming. Writing modular, extensible, easy to maintain software which avoids the use of objects. Not because they're particularly bad or anything, but it's just extra cruft you really don't really need, except when you really, really need them. And relying as great as possible on early bound Forth semantics. And there's a very good reason why I encourage that. We dispense with object orientation. It eliminates most of your containment and ownership issues. So one of the things that pops up frequently in object-oriented programming is, how do you keep track of resources? 99% of object-oriented languages have adopted garbage collection as a way of basically freeing the programmer from having to think about this. So yes, early bound means when you reference a procedure name or a Forth word, the compiler knows its address at compile time, and therefore can encode a control flow transfer in one instruction, one CPU instruction, typically a subroutine call. Late bound, which is the opposite, involves looking up the implementation of a procedure at runtime by way of an indirection, say through a C++ vtable, for example, or in the case of Smalltalk or Objective-C, for example, which is popular in Mac OS X, it will actually resolve this at runtime by looking up through hash tables. It'll actually resolve a symbol name at runtime, basically. No. Indirect threaded code in Forth would be early bound because the compiler knows the execution token at compile time. So you are jumping indirectly through the word header, but that's an implementation detail. And it's not typically used to select one of n implementations for a given word. So on the other hand, if you say defer foo and you call foo, that would be a late bound selection, because then the meaning of foo can change depending on context.
So in early Bitcoin implementations, there were a few words that were sort of filled in after the fact. Late down?
Question was, if in early FigForth implementations there are words that are filled in after the fact, are those technically late bound? If you were to split hairs, yes, but it's more a question of intent. In this case, it sounds like it's attempting to resolve a forward reference. For example, right, to avoid a two-pass compilation. So in that case, I would say the intention is not to have, how can I say it? Not to have a context-dependent interpretation of that one word. Whereas in object orientation, if I tell an object to draw itself on the screen, exactly how it draws itself on the screen will depend on the type of that object, and that type is resolved at runtime, if that makes sense. It's the same indirection mechanism. You're still calling through a vector, but the distinction is really what it boils down to is if something goes wrong, how easy is it for you to debug it? If it's very, very easy for you to debug, it's probably early bound. If it involves you having multiple debugger windows or text editor windows, and you having to insert print statements to see which method is actually called, that's probably late bound. So yeah, basically, going back to the memory management issue, like I was mentioning, garbage collection is typically used nowadays to free the programmer from having to deal with that. But realistically speaking, in most programs, you really don't need garbage collection. So then in C++, for example, they use a different mechanism, as well as Rust. They both use a different mechanism called RAII, or Resource Acquisition is Initialization. It's a bit of a mouthful. These things are nice to have, and in some cases necessary, but they are very niche cases when they become necessary. Generally speaking, you don't really need them. Other things like law of Demeter, single responsibility principle, the solid principles, and other rules of thumb, these things tend to be automatic when you work with aesthetic programming. Whoops, I keep forgetting that I cannot scroll down that way. So sometimes, like we were just discussing, containment and late binding and things like that, those are advantageous, but generally speaking, it's not necessary. So when you do have a need for late bound behavior, it's always good to make it explicit in the source code. And with aesthetic programming, it is very explicit. Not so much that it's a burden, but it is, it takes like 1 or 2 lines of code. And when you look at the code and you examine it statically, you can actually say, oh, okay, this is a late bound operation. I can respond accordingly to that. But we also dispense with language enhancements, right? So like what I was mentioning earlier, which syntax exactly do we use for object orientation? Do we use Will Baden's contribution for Figforth? Do we use something for Forth 79? Ants Forth? Do we use Forth 2012? Do we use Swift Forth, MPE Forth? Which one do we use? So basically, we want to get rid of a dependency on a package or an extension to the language because it minimizes your dependencies, and that's an important consideration, right? It's easier to publish code. It's easier to reason about the code. You can talk about it more generically, and it eliminates duplication of intent in code, right? So you don't have 14 or 15 different object frameworks trying to cooperate and compete with each other at the same time. We rely heavily on self-discipline, as I mentioned earlier, much more heavily than other programming approaches. In particular, last year talk was declarative, inquisitive, then imperative. That process, aesthetic programming builds on that in exactly the same way that extreme programming builds on test-driven development. So with only a small amount of practice, it'll feel uncomfortable at first, but with a small amount of practice, you'll find that writing this way becomes largely automatic. And there's certain conveniences that it affords you. But more importantly, per Chuck Moore, things which can happen earlier in the development cycle should happen earlier in the development cycle. Right? He mentioned the 3 basic times. You have edit time, compile time, and run time. Right? So we want to make sure that we optimize. We want to front load as much as possible on these 3 times as we can. And the result is a smaller program, simpler architecture. It's faster to execute because early bound control flow is typically at least 2 to 3 times faster. It's easier to debug because early bound behavior, you can think reasonably about it, and it's easier to write because it's less boilerplate code overall. Or if there is boilerplate, it's more confined into specific modules, right? So let's take a look at some of the concepts behind aesthetic programming. Instead of objects, you have entities. Entities have an identity, just like in object-oriented programming. You can actually say, okay, this is entity 42, for example, but they have no address in memory. So it's just a label, really, and that binds a bunch of related pieces of information together. And each module, we'll get to this, and I'll talk about this in a bit, but each module maintains its own chunk of relevant data for one or more given entities. And so this entity ID is used as a foreign key, if you will, into a relational algebra of different chunks of information. So we've got some definitions on here. We have two words, entity and retired. Entity just creates a new ID. And retired, as you might expect, frees an ID. Now, retired may or may not actually do anything. For a 16-bit fourth, you're probably going to have to reuse and recycle entity IDs. But for a 64-bit fourth, you'll probably die of old age before the planet's entire 7.5 billion people who are repeatedly calling entity causes it to overflow, right? So it's the more bits you have in a cell, the less need you have for explicit retiring of data. But the nice thing is you can allocate entities all you want, and your memory, in most cases, in most implementations at least, your memory should not be burdensomely consumed, because you're not actually allocating chunks of memory per se, except maybe for metadata. And as I indicated, it is a relational algebra between different modules that work with these entities, right? So I rely on relations to replace the notion of typing, for example. I can create an entity 5 that may be a scoreboard in a video game, for example. And that score is a visible thing. But entity 6 might refer to something in a data file somewhere, right? So it's when you create the entity, it doesn't really matter what it is. And they can actually change types as time goes on as well. Yes?
Is this in any way like related to linear naming the entities? Where you only use a name, you use a variable only once? You retire them, yeah.
That's an implementation detail. Yeah. So the question was if my use of entities was related to linear naming, which I won't go into. Basically, it's the executive summary is when you allocate something, you will never get that something back again, even if you free it. The idea is, and you can only use it once and once only. So there's like Rust's memory management and the ownership model is based on linear algebra for that. Not related to mathematical linear algebra, memory linear behavior. Very confusing. That's one of the reasons why I'm going to skip talking about that. But basically, no. I define entity and retired as together because in most stateful programming, you have operations that exist in pairs. Something to create, something to destroy, something to print, something to input, that sort of thing, right? Having that symmetry is very valuable. And I encourage retiring entity IDs when you no longer need them, even if it's a no-op operation. Yes. Yeah.
Do you have a debug implementation of entities maybe that would let you associate a comment with the IDs?
There's no need for that. So the question is there a debug infrastructure that allows you to associate a comment with an entity? And the answer is no. There's actually no specific need for that, because if you were to write something like that, it's just another module. It literally shows up as just another fourth module at that point. And I'll show some examples a little bit later on. Well, I'll show an example a little bit later on about the structure of what a module looks like. Keep in mind that I'm still hashing out this talk, so I value your questions because it tells me what I need to work on. But hold that thought, and we'll revisit that a little bit later. Let's see here. Let me check my notes here. So yeah, so once you can identify entities, you can record facts about them in various tables, right? So that's where the relationships come from. But relations also replaces containment as well. So one of the big things in object-oriented programming frequently is you'll see what's called train wreck programming, where you have a pointer to an object, arrow, field, arrow, field, arrow, field, arrow, field, and then finally you get to whatever it is you need, to do. This is generally not good programming practice. Like I said, there's a single responsibility principle, and then there's Demeter's law that controls how far that chain goes, basically. But nonetheless, you'll see it out in the wild because this code is very fast, right? It's like, why bother making all these decisions, especially at runtime, when you can just traverse a bunch of pointers and get to the information that you really need. Relations in aesthetic programming dispenses entirely with that. So as a result, there's no chaining of pointers or anything like that. Instead, you're expected to rely on relationships. That being said, it is possible to create a module that kind of aggregates relations across multiple other modules as an optimization, for example. But that's exactly that. It's an optimization. Basically, anytime you have a hierarchy that you can traverse, that's usually indicative of a premature optimization. Right, so relationships implies set membership, which is more expressive than types, both static and dynamic. Let's see here. Most uses of containment in an object-oriented programming is to maintain close relationship with the contained object, right? So that's kind of what I was talking about earlier. A more concrete example of that would be when in a model view controller relationship, when a model changes, the model is responsible for updating all of its views to update their display accordingly. So for example, if I type in a number in a spreadsheet, that spreadsheet will know to update any graphs that include that cell automatically. So that's kind of the relationship there. Controllers need to know what that model is, right? So when I'm actually typing something on the keyboard, the user interface has to know, oh, I'm talking about this particular cell, right? So there's all these references that have to be maintained and tracked. And that's partly why garbage collection has become so prominent in object-oriented environments, because when you've got it's not just a directed acyclic graph of pointers, it's actually cyclic in many cases. And then relations tend to be strategic and not tactical. So what I'd like to do is distinguish between those two. And I may be using these terms wrong, forgive me if I am, but strategic code tends to be problem oriented, right? It's my strategy for solving the problem on hand. Tactical code tends to be more boilerplate. For example, factories, singletons, configuration management stuff, anything involving, grabbing environment variables, for example. These sort of things tend to be tactical in nature because it really doesn't contribute to solving your problem, but you have to have it in order to implement your strategy. So that's where I distinguish strategic from tactical code. Most object-oriented programs that I've written, maybe about 20% of my code is strategic, and 80% roughly is tactical. And this goes for Python, this goes for C++, and Java as well, especially Java. Whereas I find with aesthetic programming, that ratio is more balanced or even reversed. Yes, there is still tactical code that you have to write, but it's not as much. It's much closer to 50-50 And in the case of equilibrium as a specific case, it's closer to 80% strategic and 20% tactical. Demo and code review, which I don't have yet because I haven't written it yet. I will definitely have something by the time of fourth day. But my goal here is to have an implementation of Connect 4. Why Connect 4 and not Equilibrium? I'll tell you. It's because my video game, Equilibrium, relies on an old version of G4, which no longer implements the foreign function interface the same way that the current version does. And as a result, I can't get it to work right now. So I'm just going to make something that runs in the console instead of relying on graphics.
The goal is to have something that's simple and can be understood. So much the better.
Yes, exactly. So the goal is to have something that's simple and understood. It's still going to be implemented in an aesthetic style, but at least it will run and not have a ton of environmental dependencies as a result of that, right? But these are the types of things that you can look for in this module, right? So score indicators, game board, individual checkers, these are all different types of entities. But when you look at how you break down the functionality of these things, each facet of their functionality will form one module, right? So there will be a visible module. There will be so like a checker, for example, will fall if you release it, right? Because in Connect 4, you put it in on the top and it slides down, right? So there will be a gravitational module that supports things that fall due to gravity, that sort of thing. A human player and a computer player, you're probably going to have a player module and then another set of modules on top of that distinguishes the two, right? So there's going to be both polymorphic and non-polymorphic behaviors, but you're going to see that the ratio of polymorphism to non-polymorphism is very, very small compared to typical object orientation. Here's an example, very, very crude example, by the way, high-level overview of what a module actually looks like. So where's my mouse pointer here? So basically, a module is responsible for its own memory management. No matter how this is done, whether it be garbage collected or not, whether it be just a simple lookup table, or whether it be hash table, B tree, if it's statically allocated or dynamically allocated, all of that is behind closed doors. You're not supposed to know the details of that. Public versus private interface. Obviously, since we're talking about writing modular software, you want to stick to using a public interface, right? And when you look at how you write the code, you're going to find certain patterns repeat over and over and over again. Generally, private words will be imperative in nature. That's just the nature of the beast. Public words, on the other hand, are either inquisitive or declarative, right? And the public interface should always be idempotent. So if I, for example, tell something that is, where's my mouse pointer? So if I, for example, want to declare that entity 5 is something visible on the screen, I would put 5 on the stack and call visible. And when you look at the implementation, you have not visible appear. Okay, well, on the surface, people here probably aren't really familiar with DITI programming style. What this is really saying is, at this point, in between these two words, at that point in the program execution, I know 100% certainty that entity 5 on the stack is not visible. That is what that code is saying. Therefore, at this point in the code, I know it is now visible because I've forced it to appear. That's how you interpret this line of code. When you look at, for example, not vis, when you look at it, it's actually enforcing that invariant. If this entity is visible, then we just exit. It's already visible. That enforces the idempotency of that word. Otherwise, we just return. Yes?
Again, people might get easily confused. I'm confused by your use of the word idempotent in this context.
Okay, so what? What does idempotent mean? Idempotent means, actually, I'm glad you asked because I was just about to get there. What this means is I can say at the console 5 visible, and that will make entity 5 visible. Or if it's already visible, it will do nothing because it's already visible. What I'm doing is I'm stating a fact, and it doesn't matter how many times I state the fact, it will either make it true or it will enforce that it is true. And the distinction between the two, you can go back to my DITI talk from last year's 4th day presentation. I go into it more there. But basically, long story short, I can call visible 100,000 times given the same inputs, and it will always produce the same outputs with, without any excess memory consumption or anything like that. Yes, a state change happens on the first time, and I may allocate memory at that time, but after that, it's basically a giant no operation because it's just stating the same thing over and over and over again. And then also, you'll notice that in the implementation of the logic for checking to ensure that something is visible or not, I define a word, visible question mark, which is a predicate. It's an inquisitive word, which basically says, starting at 0 and going through all records, they are all invisible. And if so, drop everything on a stack and return 0, the flag. So this is stating exactly what I was saying before. At this central point of the code here, where I return the false flag, all this code up to this point has been to establish a truth. Is not to make a decision. It's not to, or at least you don't think of it in terms of making a decision. Decisions are made, of course, but they're localized. And then finally, invis is another word that basically knows how to access the database. Here we're actually touching the metal of the actual relationship table. And we're checking to see if it is in fact invisible, and if so, manipulating the return stack. So now things are getting interesting, right? So a couple of things to notice here. Most of your declarations have a corresponding query word for it, an inquisition. All of your implementation details tend to be imperative, right? And finally, your control flow can be as hairy as you want, but as long as you only call the public interface, it's dirt simple. You never have to think about it. Because all of that is encapsulated in these, 5 lines of code? But what happens if you do need polymorphism, right? So like I said, in a video game situation, you've got different types of objects on the screen, and they all need to know how to render themselves accordingly. Well, the way that you do that is you communicate using explicit callbacks. And if you'll notice, most of your callbacks are actually imperative in nature. So here we're expanding the definition of visible. And here I've actually provided, now that I've had space at the bottom of the slide, an interpretation of that, right? So if the entity is not already visible and there's room for another row in the visibility database, then record the entity and its draw procedure in the table, then make it appear, right? It's very, very simple when you know the convention of how to read the line of code. So in summary, these are the common elements that seems to happen over and over and over again, right? So modules are solely responsible for managing their own memory, no exceptions. Modules encapsulate knowledge. They don't provide functionality in the sense of, say, a Modula 2 module, for example. They're knowledge keepers, facts as they pertain to one or more entities. Entities have identity, but because they lack an address, they have no proximity. There's no way for you to say, here's a particular, member field of an entity. And non-polymorphic public interfaces tend to be declarative and inquisitive in nature. I won't say 100%. I'd probably have to clarify this slide to say that, but it's not 100%, but it's up there, right? It's well over 80% of the case. Polymorphic interfaces, that is, things that make an entity unique amongst others, those tend to be imperative in nature because they're implementation details by definition. Not always, again, but the vast majority of the cases, for sure. Now, this is the downsides, right? So what's wrong with aesthetic programming? Why wouldn't you want to use aesthetic programming? Well, aesthetic programming is not fast programming. You actually have to put in a reasonable amount of thought into how you build your modules. Yes, they're self-contained. You can test them independently. You can even parameterize them, right? So you can actually rely on Forth's hyperstatic global environment to actually define definitions before you include a module, and then you declare aliases, name specific aliases for them. You can do all sorts of stuff like ML functors and whatnot. You can simulate that. But it doesn't really help you in really defining what it is that you are getting at when you're solving a problem. The only way to really know how to solve the problem is to solve it. And that means a lot of iterations and a lot of development cycles, right? So your interfaces will change over time. Your modules will split. You'll probably join modules again, right? So it's a living, evolving ecosystem. So don't think that aesthetic programming will suddenly improve your productivity by a factor of 10. It will not. It will compare. What will improve your productivity by a factor of 10 probably will be test-driven development, which is an orthogonal practice of this. I do test-driven development with aesthetic programming all the time. So moving on, aesthetic programs are not fast programs. They're not terribly slow. They can be, especially if you do full table lookups for all your entity lookups, your entity relations. But you don't have to implement. In my code is so simple and so small, I just use full table lookups, and they work fast enough. If you are writing an enterprise-grade piece of software, you probably don't want to use either static allocation or full table lookups. You want to use something more dynamic, like dynamically allocated records, and then index them with B trees or hash tables or something like that, right? So you have options there. You can make trade-offs. But aesthetic programming is fast enough. So if you think about it, the worst case scenario, a Forth program will be as slow as a Python program. And the reason for that is when you reference train wreck code in Python, every time you have .member, whatever, it's actually doing a name lookup in a hash table in a dictionary structure in memory at runtime. It's one of the reasons why Python code is so much slower compared to, say, C or C++. Forth code would suffer the same thing under those same circumstances. So there is a lower bound to performance. It's not going to be super fast, but the fact that we're running Python code on the internet today, not even PyPy, like literally CPython, the original Python interpreter, is running code, user-facing, customer-facing, every day, billions of transactions per second. It's fast enough, right? So if you're going to be doing this sort of thing, if you're masochistic enough to write Forth code and have it customer-facing on the internet, it will definitely perform good enough for you. It may not perform good enough for you for a massively multiplayer online online game, but for most applications it'll be fine. And like I mentioned earlier, just as test-driven development enables extreme programming, so too does declarative, inquisitive, and imperative enable aesthetic programming. I would really encourage, if you want to practice working with aesthetic programs, I would really encourage learning DITI first, getting used to how it works and how to debug, because you will be debugging. Just get used to the mechanics, and that's aesthetic programming in a nutshell. And I think I'm right on time. Yeah.
Was that I3? Was that I3? It is I3, yes. Part of the reason why I was like, what screen is that on? I can never remember the order.
How well does it do multi-monitor stuff?
Oh, it's fantastically. Well, I use XRNR manually, but if you use something like Ubuntu Linux or whatever, it's pretty much automatic. But yeah, I run VoIP.
What's the display?
All right, we're done. It's the word of the day. So that's the double otter face plant, which I enjoy you to have a nice break. So take a little break down.
The upstairs bathroom is open that direction.
Until you want to use it.
Well, I actually used it.
Okay. So that must not be the you to which I'm referring.
Yeah.
You can close it any time.
It could be closed right now.
Well, what the hell is that?
It's Schrodinger's bathroom.
You don't know if it's closed or not.
It's in both states at the same time. So what's line 5 like?
It's an array-based schedule language, and also I've been working on projects for the staff.
Oh, I see.
So instead of a stack, you can operate it. So
Wait, that's like the structure that you're always operating on. Oh, just your parameter passing.
the parameter pattern, but I'm also thinking about how I use that to replace your transfer.
Yeah, I mean, it's so hard, had it for years.
I was going to make just a stream, like an ordinary kind of value that can be on the stack.
Yeah.
So the idea being that like you have some more primitives for interacting with it, but like it's a stateful object.
Yeah.
I don't know. Maybe not. It's not a great idea, but like I really like the level of richness that you can get with languages like Fortran APL, where sort of where like most of the control flow is implicit, and certain other things like managing variables is also implicit. It seems like the thing that makes it hard to use for ordinary production code is there's nothing resembling a type system. Like I can't just look at the API for a function and ignore almost all of the details and be like, okay, I kind of understand what that does. It's hard to walk into other functions and understand this.
Yeah, that's partly what
You should sit down at the laptop.
I certainly don't think it would solve the problem by itself. My hope is that by ensuring that code consists entirely of a self-contained unit, that it's at least easier to document or easier to recognize. One of the problems that I had, like early on, one of the big beats that I had, especially when trying to implement my own work for my homebrew gear, is that I noticed that this word depends on this word, this word depends on that word, and it's like, holy shit, like I can't just write a small chunk of code and then test it. I can't write, you
Need all the words before.
I needed all the, like, it was all or nothing, and it was like, I couldn't, just couldn't function that way.
Now that you say it, I kind of didn't like that when I was like I was using 16 mega and I had to upload the radio driver every single time I had to drive something to upload it.
So in terms of this kind of hidden word dependency, that a fourth word can have inside of it like a reference to, or inside its definition literally a reference to a word that's underlined, and you're expected to fill in that definition yourself before using it. Or
If it's a deferred word, you can do that.
right.
And technically, a deferred word is an actual fourth word, so you're not really just referencing one word. It's just a word with undefined semantics. But the word exists.
Wait, what happens when control gets
Typically, it'll execute a procedure, a predefined procedure that says undefined word, and then we'll drop it to it.
Oh, I see.
Right. So it's not like a null pointer or anything like that. I suppose you could implement a work like that, but you'd be crazy to do it.
Okay, it literally transfers control directly to the debugger, which is also the interpreter. Right. Yeah. Right.
There's also another thing you can do is some guy came up with this idea where you fetch the pointer to the body of one word and store it in the pointer to the body of another word that you compiled.
Yeah.
So then you get the hyperstatic scoping of a word that's shadowed, the shadowed word scope later on. You can save the scope, hyperstatic scope.
What is hyperstatic scoping?
So
I don't know the scope rules before. I just assumed everything was global.
Okay.
I'm really new to this.
It is. Everything is global. But and that's why it's called hyperstatic global environment. But here's the thing. In most languages, you're dealing with either dynamic or lexical scope. Right? So old school Lisp systems were dynamic scope.
When run an interpreted mode.
When run an interpreted mode. Which old school Lisp systems but yeah.
Yeah, I thought some of them had both, but the semantics would change.
So common Lisp definitely has both.
Yes, but the semantics are pretty similar.
Right. Lexical scope came about because people were like ripping their hair out because, oh my god, I can't keep track of this shit, you know. Hyperstatic global environment is the third form of scope.
Okay.
It is literally lexical scoping on steroids. So what happens is, I can say, colon, hello, hello world, whatever, right? Yeah. Call it any number of times and you'll happily pronounce hello world. I can then say, colon, hello, goodbye hello world. And then anytime I call it, it'll happily pronounce goodbye. But any definition that you make between those two definitions will still reference the old one, not the new one. So you actually have two implementations of hello that both behave differently, but all the old code still refers to the old definition. The newer code refers to the latest definition.
Oh, okay. So I guess this is not so much about how scoping works, but just what it means to define a word.
Right.
Well, like when you define a word, you're not defining it as literally execute these words, but execute what these words point to currently.
Yes.
Okay.
The latest definition. And which means you can compile a new library, the same library, and on top of the old one, and the old words will work the same as they did before underneath, and then everything after is sort of like shadows that came before, unless there's some like other words being
Which I've used to good effect. I have implemented like hash tables before, but I needed to implement hash tables for different sized objects. So what I would do is I would say colon size of whatever, define my constants or whatnot, include the hash table definition, alias the default interface to that module, and then change
Take care of yourself.
And then re-include that.
Stay hydrated.
Now I've got two hash table
Oh, wait a second. So you're talking about using like a library definition and importing it almost as if it were a procedure.
Or a template, yeah.
Or a template.
Like a C++ template. Like basically in a, so basically you can parameterize modules. I didn't show an example of it here, but it's a really undervalued hack, really, as most things are. But it definitely is useful, especially if you're dealing with abstract data types. I need a list of stuff, right? So you define your default to be a cell externally to that module. So you basically have a dependency on that thing in your module. then you include that module, and now suddenly your module is specialized for that particular thing.
So do you have a way of saying, no, really, get me the thing that currently resides here at execution time?
What does that mean?
So in your hello example, or in your H example, where I redefine it to say hello and then do bye. So if I, colon H hello, and then I define something using H, let's call it G, and then I define H goodbye, and I call G down here, then it'll print hello, because it's still pointing here. Is there anything I can do inside the definition of G to say, no, really, get me whatever's at the current value page?
So there's open bracket, say, close bracket, which is a compiler word. That pre-parses the next word out, and it says, compile the execution token of that pre-parse word here as a numeric function.
Oh, okay.
So it's still hyperstatic, but you have the ability to take the address of something.
Okay, wait. So that means when I redefine something, when I redefine that redefinition in a certain sense happens in place. That redefinition in a certain sense happens in place. In other words, like if I use tick to get the address of whatever is at the word H, and I redefine H, and I take tick H again, that number's not going to change.
That number will change.
5-minute-ish warning, time check.
From the time that you first, so like, let's say.
Unless Andreas isn't in the front of the room by then, in which case it's going to take longer and cost more. We have a schedule, damn it! A schedule, I say!
So you have.
So what you want are
call it G.
stencils.
Tick H.
It just occurred to me
that
you get a stencil of
so does tick H pick out
whatever
it
it is,
like a reference?
and you just sort of
it's
spray graphite.
It's an untyped reference.
Actual graphite instead of a pencil.
But it's referenced like
Graphite in the tube. Well,
does it get a reference
if the
to
spiral
like
thing works for the inductor, that's you can get a stencil and make those spirals real quick. Have you used graphite yet? Or are you still using pencil? Like H1 pencil.
Yeah, I'm using pencils now. I don't know graphite powder yet. I also, so yeah, I could use, I could cut out with like plastic out of a piece of cardboard or something. I could cut out a stencil.
It was an interesting idea.
I don't know how a dem. What was that?
Oh, I see.
So you're actually evaluating at runtime.
Yeah, lots of languages have
That means that you're
I'm still right.
Okay. So
thanks for doing that. Yeah.
So the way that
Don't forget the luggage tags. Did you help yourself to a luggage tag?
But the only way to defeat the mechanism for redefining words and leaving yourself saying is to literally
Collected books that I had, like
H or something, just to
so I'm gonna compare that against what is already out there to make sure I don't have any ones that I have. Archive those off.
You have spreadsheets, so
yeah, we do.
So I also have these large files, boxes with files of documents, which are unavailable and have not itemized in the spreadsheet yet. I got them not from Matthew Press, but from some other guy.
Are they just loose files?
Loose files, loose files are small booklets.
Okay.
And
those are easy
to scan.
Yeah.
Whoops.
Whoops.
There's also like the first
Really? If you want, bring those. And yeah, those are so much easier.
Yeah, you can just take the box.
Go through, because, I mean, since those are historic in nature, right? Once those get archived,
create a kind of definition that's
does that guy,
when you're compiling
I guess
something.
in England,
That's visible only.
Oh yeah.
does he want any of the originals?
What were you,
I mean, the thing
what
is,
were you
I
talking about before?
you know, I'm keeping all the documents together.
He takes PDFs, he takes
When you
scan, and he'll send them back to you after
Well, I was just curious, because I've scanned these already, right? So I'm just holding on to them.
You could email them to him. The Jupyter HR has sometimes like goes down for maintenance, but it never goes away.
Sure. So he wants the PDFs, but he doesn't want to.
He doesn't need the original, he just puts the
Okay. I just wanted to, you know, I didn't know if they actually wanted originals, personal collection, or, okay.
So what you ended up with was.
Yeah, I gotta look at that list.
Reference each other.
I was trying to get that done before the end of the year. You know, I've got this whole montage of projects that I'm doing. You know, I'm trying to
I'm
create.
still sort of confused about how that works. Does that mean that you have to, for like, okay, for a word that's
I've got a
automated to
C64
be part of
project that I'm
the
really
API
getting into.
or whatever. Do you have like some special magical staging area where you can define stuff and then a way of saying?
Address,
see it?
mic'd up, good to go?
Pies, or not pies, but actually. 6502 version is like.
Take it,
Cool.
stick it, they say. It's a technical language.
Oh, I can put this in my pocket, right?
Yeah.
Okay. Just no, the microphone is up here. Okay. Yeah.
There's no way for you to say, okay, pull and food or plot and then truncate food. Like, there's no way to do that.
So,
But on an older system like Picnic Board, for example, you'll go, if you look through the source code of Picnic Board, you'll see a lot of pipe, colon, plot, pipe, colon, plot, pipe, colon, plot. And then at the end, you'll see truncate. And that word truncate takes all the pipe definitions and gets rid of the headers.
It's gonna work.
And that's where.
okay, I see. Okay, so it's a special kind of definition that will get truncated when you say.
Need to try.
Well, the dictionary entries, just the way.
Yes.
You just can't represent it.
Right. So basically, it seals it into a opaque pattern.
I can talk for like 5 minutes.
Oh, we had that already. Okay, sure. Why?
I thought it was semantics.
You're relying on the schedule again. Okay.
You're talking about the schedule so much, I thought it would
I'm
actually.
sorry. I should not provoke you needlessly. Yes, that would be great. Thank you. I appreciate you reading the schedule. I appreciate you tolerance my idiosyncrasies. Let's all be quiet and listen to Andreas. Then we'll have a little more stuff after.
All right. So I am Andreas Wagner, and I have been thinking about what would happen if I was stranded on a desert island, and if I was stranded on a desert island, how could I still write Forth code? Well, probably I'd be trying to crack open coconuts to survive, but how could I still write Forth code stranded on a desert island with nothing more than a ream of paper and a box of pencils? So first thing is resistors. The softer pencils have more graphite content. Graphite is a crystalline form of carbon, which is more conductive than the harder, more disordered, high disordered carbon content pencils, which are more resistive. So, furthermore, there is graphene, which is a single layer of graphite, and it's even more conductive. There's innumerable applications of graphene. Some people say it's it would replace silicon as the semiconductor material of choice, but it's very difficult to manufacture a lot of pure graphene. but we can also, but the easy way to do it is to peel off a single layer of graphene from a area of graphite with a piece of Scotch tape. And this actually does peel off a layer of graphene, which is more conductive. And yeah?
When you draw a box, a square using pencil or graphene,
Yep.
it has a certain dimensionality, and that's called ohms per square.
Ohms per.
So any square of a given material has the same, you measure the same resistance from top to bottom, left to right, or dimension, or diagonally, independent of the size of the square. So ohms per square.
Yeah. Well, if you also if you move your if you move the point A and point B further apart, you get more resistance.
Right.
It's like a variable resistor.
Yeah, but that's a rectangle, not a square.
Yeah, it's a rectangle.
But I'm saying any square has the same resistance. Any square, tiny to big, is the same resistance.
Conductive path through the square, whichever.
Yeah.
So that's a particular interesting dimensionality that a square of graphite or graphene will have.
That's right. Yeah.
Conductive paint for anything that is essentially a two-dimensional surface.
Mm-hmm.
As long as they're across the diagonal, the resistance is going to be whatever ohms per square for that material.
Yep.
So you buy conductive paint and you call up the manufacturer. It says ohms per square what? And they say, oh, it doesn't matter as long as it's the diagonal corners that your probes are at.
Yeah. Yeah, I've started tabulating the ohms per square for different pencil hardnesses. Not done yet, but I started tabulating that. But of course, it also depends on how thickly you layered it or so. But it's not exact.
You need to make it the same way. Because I remember doing this for a homework assignment in college.
Yeah.
Okay, sorry.
No worries. Yeah, interesting.
Another thing about graphene.
Yeah.
It's actually stronger than diamond.
Strong. It is?
Yes, because of the inner atomic distance is smaller in graphene than it is in diamond.
It's just very thin.
It's just thin, yes.
It's just a single layer of atoms thin,
layer.
yeah.
It's this, the pulling apart, much stronger.
In the diamond form, yeah.
Diamond, right, yes.
Yeah.
Go, please, continue.
So next would be capacitors. This is the next easiest one to draw. And the paper can serve as the dielectric, and then you have the two plates, which are just lines or boxes you draw on the page. And the paper has a dielectric. And but also remember that the paper has two sides. I forgot this at first. And behind that is also you can also have a circuit on the other side, and the dielectric would just be as thin as the paper there. And you can also stack several sheets to get a multi-layer circuit. And I mean, they'd be connected by sort of a very thin capacitor, yeah.
If you ever look at an electrolytic capacitor,
yeah,
it's just basically the substrate that's just rolled up, like this.
Yeah.
Okay, because if you've ever blown a capacitor, you just see this. It's just like confetti. It's just this long goes.
Yeah.
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 So yes, that's yeah. You can make literally relatively larger capacitor. What you have up there is 40 farads, but if you have a long sheet of paper that's conductive on one, it has the carbon on one side, you can just roll it right up.
Yeah.
And you get a larger capacitance out of it.
Yeah.
Yes.
Cool. Yeah. Yeah, and you can make multi-layer circuits this way, and that's sort of how I would do VIAs in a way, without putting a hole through the paper. Then there's one I forgot was to do inductors, but it seems you would just do like a spiral or something like that. Yeah, and that I think would work. Probably the next easiest to do. And then this one was a bit tricky to get working, but I did. And it's this right here is a ballistic geometric diode, which works like a funnel, and the charge gets, the electrons bounce around inside and get funneled in this direction and go through the neck to the cathode, and but electrons this direction would just bounce off. Most of them would just bounce off because there's just a small neck there. And at first I thought this would only work at the nanoscale, but then I made a tiny gap here, and for some reason with that it works at the macro scale. And I measure with my multimeter, and I get a negative voltage for reverse bias, which seems right, and a positive voltage, positive voltage for forward bias.
Okay, so I do understand this stuff. So what you do is you have your thing that looks like home plate.
Yeah.
And then there's this little gap and then the rectangle. So that if you put a positive voltage on the rectangle and a negative voltage on home plate, you reverse bias the diode. You won't get much of a current.
Yeah.
Right? Switch it around, and you will. Now, here's the thing: is there tunneling that's going on? I guess. What's the gap?
The gap. It's kind of capacitive. Yeah. It's a.
So in this particular case, because we're working at the macroscopic scale, this is equivalent to the nanoscale diode structure, which is actually connected via the DNet. But we can't get small enough to replicate or to be able to measure the effect. We don't have precise enough instruments for that at this scale. So when you introduce a gap like that, that actually is equivalent to a diode followed by a capacitor. So it's still rectifying in the sense that you can pass AC signals through one way easier than you can the other way. The signal is distorted in the predictable way, right? So it'll only pass like the positive peaks, for example. Right. Whereas the negative going peaks will be attenuated significantly. Okay. But it is interesting to see that it is actually capable of some amount of rectification. I won't say it's as good as a silicon diode in this particular case, but it's interesting that at this scale you can actually see the effect. That's fascinating.
Yes.
A diode will pass to DC. The reason it's working is that it's rectifying AC. But you could not use this as a diode in DC.
Correct.
Yeah.
Yeah, it will not pass forward. So because
like you said, it's really a diode followed by a capacitor.
Yeah. On the scope, I see it sort of a wave, so it's not. But
we'll be able to see it. Yes.
Yes. I don't know whether it can be on the live video, but so there's other diodes. Just to finish this off, there's some other diodes. There's a lot of ways you can make geometric diodes. You can also make a bow tie, which is two of these tips pointed at each other. I don't remember what the purpose of that is. I read about it somewhere. You can also make a Z-shaped geometric diode, which has apparently even higher asymmetry and other performance characteristics. And so yeah, I sort of feel at this point like this is starting to feel like a little bit like chip design, where you're actually drawing the components, not just the traces to components, as we do in PCB design. And then, but what about active switching? And there's this guy, Scott, who was able to make a pencil and paper transistor. See whether I can get the volume up. Nope. For some reason, it's not working. I don't know why. But
You have to have the other wire plugged in.
oh, this one.
It's a little. Maybe.
Is that gonna work? Now it's not letting me.
Is there a volume control on the wall there?
Yes, there is.
Oh, there is.
Black, panel with the lights on.
Oh, this one right here?
So this is not an amplifier, this is a switch.
This is a NPN, it's sort of like it's more like a JFET transistor. Yeah.
That's what I'm saying, it's basically using it as a switch.
I think I'll just go to the, well, it's kind of hard to see in this video anyway, so, but you can find it on his little project thing here. And the video's not really working, but then I tried making an antenna right here. It actually works surprisingly well, and I put my I put a power brick over it, a plugged-in power brick over it, and I get 60 hertz on my oscilloscope. And when I take it away, I get a flat line. So it's a square space-filling tree, fractal antenna, and it apparently works. And then thinking about touch input, you can do this with a piece of tinfoil, also with a filled-in area of graphite or graphene, and you can use your finger. Your body holds a lot of charge, and moving your finger changes the distance, or it's like a variable resistor, and you can see that on the scope or on the multimeter. And I was thinking about how to remove that ambiguity between X and Y. I was thinking about having a aperiodic pattern, maybe like a Penrose tiling or something, to distinguish translation, XY translation. So because the Penrose tiling has no translational symmetry, and that would be a way to get distinguishable XY. Perhaps. I haven't tried that, but it's just a thought. And Sam Falvo, who's also been playing around with this, he said he has, if you punch holes in a piece of paper and then you have a sheet of filled-in graphite below and then another page on top, I think, then you get a membrane switch, like a membrane switch keyboard. And that works. Then thinking about how I could get a memory, which I was sort of envisioning that I want to have a book of graph paper where I fill in the bits in the squares with my fourth image. And then I have a book a fourth book that can run, and so yeah, it would. My thought is I would have I could do either like a resistive matrix or a diode matrix or a capacitive matrix memory, and I was sort of leaning towards using this hexagon graph paper that they use in chemistry classes for molecules because it makes routing access easier, I thought. Maybe.
You can trace over the lines.
Yeah. Yeah.
I like that.
So easier access for wires or traces if you have a hexagon instead of a square.
I like that.
Yeah. So then one last thought was that, well, how do I get a display? This is something I haven't done, but I just sort of thought about it today. And I remember when I was in middle school, I made this electrostatic motor with bottles, and that could be used for perhaps a mechanical display of sorts. Perhaps, yeah. And yeah, so when will my graph paper run forth? I don't know, maybe soon it will. Soon it will.
Well, look at what the
F18?
F-18. Well, yeah.
The missed process.
Yeah.
F-18 has, what is it, like 31, 32 of the fundamental fourth instructions. That's all you have to do is just get those. And it's like with Ting, you know, how you're generating all these proteins. Well, those are the fundamental stuff.
Yep.
Then you can have above that things that call these things, these other fundamental stuff.
Mm-hmm.
Might not be fast, but it might work.
Might work.
I'm very impressed to see that.
Yeah. Yeah.
It's probably small enough that the book wouldn't be too big.
Yeah.
Have you given any thought to having like an inkjet printer use inks of different conductivity?
Yes, I have, yeah.
Miker is like that.
Yeah.
The Miker is, you know, if you know on the bottoms of checks.
Oh, yeah.
Yeah. That is a special, because I worked at a place that did check printing.
Yeah.
And on the bottom, that has to be a special, it has dielectric and I think magnetic properties.
Yeah, that's the Emmett.
Yeah, so when you've ever been to the bank, how they
used to
take your
sell-
check and they run it through a thing goes zzz, like that.
Yep.
It's actually reading that. And it was interesting because the
it's
guy told me.
optical now.
Well,
It
it's
used to be
actually,
magnetic.
I think it still is because he showed me. He said, "Now here's regular toner." He printed up a check, ran it through, and 75% of the time it actually read the thing.
Mm-hmm.
So I'm thinking, you mean I could I could create my own check of someone else's account and drain it just by doing a fake check like that.
Huh.
I just went, oh my God.
Well, one time I ran out of checks. I dropped by the branch and they printed me up a bunch of blank checks. But they actually, I guess they used to have, I don't know about these days, they used to have toner cartridges with Miker toner.
Yes,
toner.
that's what I'm saying,
Miker
yes.
toner.
This was 1999 when the place I worked at. So yes, that's what I'm saying. You know, it's like you have a special, it's like you can create your own toner formula.
Mm-hmm.
And literally print up a computer.
Yeah.
Shocking as it might seem. A two-dimensional one is really what you're doing.
Mm-hmm. But yeah, there are companies that sell graphene inkjet ink, and also I finally found a company that sells resistive ink, which means you could print a resistive layer on top of your circuit to create vias and a multi-layer circuit.
Okay, there you go. There you go.
Yeah, I think so.
Yes. There you go. Inkjet type stuff.
Yeah.
So instead of being colors, you
Yeah, I was gonna have like use the different colors for different properties, ink properties. Yeah. Yeah.
But Staples sells micro toner cartridges to this day.
Oh, are you kidding me? You're kidding me.
I'm not kidding. I just looked it up.
Literally. Oh my God.
If I didn't sell it, somebody else would. I thought that would be licensed.
That's what the guy told me.
Yeah,
Well, remember, this is the same place.
I think that the problem is that the electrons tend to leak.
Government checks.
So you know, it's very difficult to hold electrons in place.
Yeah.
And I think the paper and pencil, which is not the whole electrons. You need a vacuum.
You need a constant like source.
We have to have to invent vacuum tubes to hold electrons. And then we find that the silicon chips can hold electrons. These are only two things that really can hold electron and preserve information and also do computing.
Yeah.
Now, there is a
Graphene. Oh, what?
I was just thinking now, extend that in the third dimension, you can get material that you can 3D print.
And that's where this is happening too.
Yeah.
They are looking into how to 3D print circuits.
Yeah.
And this is that same thing.
Mm-hmm.
Is they've got to do it with effectively ink.
Yeah.
Correct. I've seen it started to come out. Now,
They're not printing circuit boards to be effective.
correct. It's real primitive.
It's real.
I don't know. Should I be done?
You're on.
Just a few minutes.
Thanks.
All right.
Can I use your laptop?
Laptop.
Yeah, this is your laptop, right?
What was that?
This is your laptop, right?
Yeah, it's my laptop. Yeah.
Will you just open a web page on it?
Sure.
Can't wait to find your book.
Over the.
Just want to open a page on LinkedIn.
What do you do? Just take
What did you get?
Where am I typing? Oh, jeez. And
Unless you want to sit there with typing in bootable programs with the membrane switches.
I'd rather not do
Hi guys, my name is Michael. I've been working on a implementation of the Lisp programming language in 4th. Yes. So, yeah. So I'm just gonna give you a quick intro. It's started when I decided I want to run Lisp on a microcontroller. Which a little while ago seemed crazy to me, but we have things like MicroPython now, so I think we need implementation of Lisp that's deserving of the name that can run in similar places. And Force seemed like a perfect language to do it in, because it already runs on like basically everything. And so if I can have Lisp on 4th, I can have Lisp everywhere too. So of course I started Googling for this, and I found the implementation. I thought I would find a better one, but it wasn't very good. Very incomplete and very slow. So I started to improve it and add features to it, and started to learn 4th because this is my first non-trivial 4th program. So it was slow because it was, how you would first think to implement of Lisp. It's just parses it and evaluates the AST. And so it's just slowly crawling over it. And it's slow because it's doing that in another interpreted language, so you're just doubly slow. All right. And even if you implement a like a bytecode interpreter or something, it's probably still going to be slow because it's still on top of 4th, and it's hard to get around that. But I learned some more 4th, and it became kind of clear that there's an obvious way to do this. You compile the Lisp into 4th code. For every Lisp function, you create a fourth word, you create a header, and you lay the words down with tick and comma and all this sort of like force stuff. And you build up your fourth to understand Lisp instead of trying to implement it on top of it. And I think that's working out pretty well. I don't have a lot of documentation for this yet, but here's a small example of what it does. You can basically disassemble here, just define a basic function called disassemble on it, which just wraps the fourth word C. And you can see what your dictionary looks like, and that's really what it is. There's a little bit more going on because words like plus are redefined. So it's not quite as fast as that makes it look. There's still a little bit of overhead. But I think it's pretty good. And it's still a work in progress, but I think it's got a lot of potential. So yeah, that's what I've been working on.
Very cool.
Yeah.
I'm definitely interested.
Yeah. Cool. Yeah, if you guys got questions, that's all I got for today. Maybe next month I can go into more some technical things and yeah.
You create a fourth word that has for a list function.
Yeah, you create a header, and then you can just lay the words down.
And just lays that so enough to where you have a list processor. Is that right? Am I off base on that?
Well, in the end, you just have a bunch of fourth words.
You have a bunch of fourth words where you can then it'll act like list.
Yeah. Basically, I mean, there's some limitations. Some of them are pretty severe right now, but they're like right now, lambda doesn't work at all. Lambda or like anonymous functions. You can't define functions inside functions, stuff like this. But these are sort of things that I don't really care that much about. Like the things that really matter to me in Lisp, kind of are work fine. I can define functions. I have macros, all this sort of stuff. I think it's pretty cool. There's words like postpone, if, and all this sort of stuff for control flow is kind of wrapped into words that I can access from force, or from Lisp. So all the functions like for if and while, all this sort of stuff, con is all defined in Lisp itself. I don't know.
So since you're compiling it to colon definitions, this would be a Lisp 1, correct? Where it has one namespace? I
want to say yes. I'm not familiar with all the different lists, but that sounds right. Yeah. It's not like Emacs list or something where functions and variables exist in separate namespaces. Yeah. Yeah. Right now they don't exist. I'm kind of planning about it. You can do that. You have like the Lisp and rest and all this sort of stuff for variable arguments too. That works for macros right now, because macros are just kind of evaluated. They're just past the AST, so it's easy to expand it and it's whatever. But otherwise, it's sort of, I guess. Yes. Unless you were, like, I could define it as, like, list is defined as kind of like a special word so that I can pass it multiple arguments. Otherwise, it's really annoying for constructing other things using inside macros and whatever. But that kind of brings its own limitations. It's not a proper function anymore, at least in the way that it's implemented. I want to implement that at some point, but I need to think about how to do it efficiently. I think it can be done, but I don't want to slow down every time, like yeah. So right now that doesn't exist.
Well, I don't know this. I don't have any working knowledge. But just by reading it, I think list and forth are the same.
I think there's a lot of similarities, yeah.
The basic principle is that both Lisp and forth solve problems by constructing lists. And the
elements in a list calls another list. Okay. So this is the fourth column definition. We build a list. In list we use parentheses. Each parenthesis is a list. And within this list, each element are mostly another list. So I think they have the same structure.
Yeah, I do feel like there's a lot of similarities with it.
That in Ford we try to build the list from very bottom, but in this it allows you to construct the list from the top, and only resolve all the references at one time.
Yeah, well, this has a lot of other things that typically comes along with it, like garbage collection and all that. But I feel like that's not really tied to the structure of the language or anything like this. So it's
It's another problem.
Yeah.
Basically, the structures of these two languages but I don't have enough knowledge about this.
Well, now's the time to learn.
And this is something that I remember Dean Sanderson, that was at Fourth Incorporated originally. He was very much a list user, and a lot of that influence he put into Ford and what he was working on. So this is, you're not new, but go great. It is.
I was hoping I would be less new. I would thought this would be out here already, but
no, it never went anywhere.
Yeah.
I think because what you're finding, the speed is a big slowdown.
Yeah.
The lisps tend to be slow, and
not so much anymore.
Well,
yeah,
correct.
You got to get a faster computer. This is your
If you get a fast enough computer, you're fine. But then why aren't you using Lisp?
Yeah, no, of course.
SVCL's pretty fast.
Yeah, it compiles to native. I mean, basically, if you can, I mean, it's like my BSPL compiler. Like, once you get it into a form where it's basically single static assignment representation, you basically have what you need to compile to native code at that point.
The other thing that I like about this is that I like the minimal dependencies that a lot of fourth implementations have. And it's not like C or something where you have this like crazy massive tool chain and all this like compiler and stuff, right? You can just have this like, you could have this running on like Jones Forth. There's like 1,000 lines of assembly and you have your system and you can read the entire thing in an afternoon. And you don't have that with if I was implemented in C or something like that.
Exactly. I mean, I'm interested in this for the Kestrel, and you know, I'm DX Forth is like maybe 1,500 lines of assembly, raw assembly, and that's it.
Yeah. Yeah.
Do you have multiple value return from Lisp functions?
No, I mean not now. I mean this is still, this is still very much work in progress, and even like very basic library functions don't exist. Vectors aren't implemented. Hash tables aren't implemented. This sort of stuff isn't. But I think that's definitely something that's not hard to do. That can be done efficiently. So I think that's reasonable.
So like, okay, if I, sorry for the follow-up question, but like, in the definition of Fibonacci, you're using the variable n multiple times in the body of the function, right?
Yeah.
Is there anything special that you do to like minimize the amount of stack shuffling that you have to do in order to achieve that?
I mean, right now the implementation of local variables is pretty simple. It's they're just as the compiler goes through the function, as it's compiled, it keeps track of the stack and the stack effects of all the functions that it calls. And for the some stack locations have names, and like for n, for example. And so whenever n is referenced, it looks how deep down it is and just generates the code that it needs to reference that. And then at the end, it drops everything. So it's not really optimal, but it's simple. And if you, that's all it's doing. So it doesn't really matter how many times you reference it. It's,
It's how much other stuff you put on the
Right. Yeah. So I mean, like the first time you reference it, it might just do dupe to get it. The second time, if there's other stuff, it might do some other thing. It might even have to do pick. Right. I think it does dupe, and then it does over, and then I think it starts using pick to get at it. Right. If you set it, it'll just do nip to throw out the old value.
So is there a way that you could do something kind of silly, like maybe borrow an entry in the return stack for like the bottom of the current stack frame for like the large list function that you're executing so that your offsets don't change over the lifetime of the function? Like give me the 0.
Well, I mean, this is the second implementation, the second way that I've done this. The first one was to have like a stack frame, basically. Like I had a variable that like represented the stack, the stack frame. That was set every time the function was called, and all the variables were compiled as offsets to that. And so every time you referenced it, it would do like one local ref, and the local ref word would just like add the offset to the stack frame or whatever. And then every time you returned, you have to restore the stack frame. But every time you call, you have to do this setup and you have to do this return. And so there's this large overhead, and it became a lot faster when I did this. So I think having a variable offset is kind of one of the strengths of this. Right. So in the most ideal sense, like I guess in the best case, you can be just as fast as Forth. There's like no overhead. But that's in the often case, like every time you do an add, it has to get rid of the type bit and that sort of stuff. So it can never be that fast, but it does help it be faster like this.
So are there operations in Forth where like the stack effect of the operation depends on what arguments are passed to it?
Yes.
Like, okay.
You can certainly do that.
That would throw off all your offsets, right?
I see, like a function that returns multiple things, or
a function that dupes an element if it's even. And doesn't.
Yeah, I mean.
Is the classic example.
Yes, yes, but the trick here is to not do that, right? All the list functions have to return one thing. Right? And in the future, we could have it like return multiple things, but the compiler would then know that it returns multiple things and would handle that, right? So yeah, there's none of that. It does have to make some assumptions and kind of deal with the slowdown that comes from that or whatever. But there's a point at which this becomes too complicated or whatever.
And not only that, but over the years, like henceforth find, for example, which is just such a word where it can return a variable number of items. General consensus, like you were talking about with different work implementers, they're going to tell you don't use find. Yeah. It's a nightmare to debug and code with, or a question group is another one. They say to avoid them like a plague. So even with plain Forth code, they actually advocate using fixed error keywords.
I was just wondering if the compiler for the list dialect, I don't know, my eyes aren't as good as they used to be. Is it rail list?
But yeah, rail list is what I'm calling it.
It doesn't like it won't. Okay. So all of the list functions adhere to this convention, and all of the things with like kind of or that don't return a single item, they're all stuff that's inserted by the compiler in order, right? Like if you look at generated code, and you look at the words that have the potential to do anything other than return a single word to the stack, those are all inserted by the compiler, right? They don't correspond, they don't map directly onto a Lisp function.
Yeah, I mean, yeah, it compiles Forth words in there along with like the words that were generated for Forth. It keeps track of the return context, and if it's compiling a Forth Lisp word, if it's laying down the address for a Lisp word that's not in return context, it automatically adds a drop after that. That's one of the ways it could be optimized. It could, you could just like not have to, because like right now there's a lot of functions that kind of have to return something because they have to return something, that return something because they have to return something, and which immediately gets dropped then. But it's simple to do it this way for now. Yeah. I don't know. Yeah. Oh, yeah, always. These are great ideas. Now, submit a pull request. All right.
All right. Yeah, for sure.
Yes, definitely. I want to see more about this.